Okay, hello everybody. Today we're going to be looking at section 29F, which is called the mean and standard deviation of the binomial distribution. So let's go ahead and take a look at the situation at hand. And let's say, for example, that again we're dealing with our unfair coin. Such that the probability of tails is 2/3 and the probability of heads is 1/3. And again, let's say that we actually do this event 2 times. So in other words, we're trying to calculate how many heads are actually going to show. So the discrete random variable could have values of 0, in other words, no head showing, 1 or 1 head showing, and 2, which is both heads showing. Okay, and then we've had the associated probabilities for those discrete random variable values. Now, in section 29D, we already showed that in order to calculate the mean, all we really need to do is calculate the expectation of the event. So what we did is we took the probability and multiplied it by the value of the random variable for that probability. So in other words here, 4/9 times by 0, plus, again, 4/9 times by 1, plus 1/9 times by 2. And when we added all that up, we came up with 2/3. And then we said that how do you calculate the standard deviation? Well, being that we did it already in 29D, let's just go ahead and take a look at the result that we had, being that it's going to take a little bit more time. We said that the standard deviation, the squared, is going to be equal to the expectation of x squared minus the expectation of x, and we said that that was going to be equal to 4/9. So if we take the square root of both sides, we actually come up with a standard deviation of 2/3. Now, of course, you can always go through this process here to determine what the mean and the standard deviation will be for any probability, probability distribution. Okay? Now, the thing though is that if you know that your event is a binomial event, like this case over here, and remember you have to show those 3 conditions to be true, then there's a much easier way of calculating the mean or the expectation as well as the standard deviation. Okay, and this is how you do it. When you take a look at the mean, we said that the mean is going to be the expectation of x, and we know how we can go about calculating that now. But if you know that it is a binomial event, the easiest way to determine what the mean is we just take n and we multiply it by p, which is, in this case, the probability of getting a head, and how many times we actually go about doing the event. So that makes sense based upon what we said expectation was, and being that this is a binomial event where the event has the same probability of achieving a head for every single time that you actually perform the experiment, then this should make sense. So what we can do then is, if we take a look at our experiment here, we know that the number of experiments or trials that we're doing is 2, and we know that the probability of actually having a head is going to be 1/3. So let's change this to h. We should change this to h as well. Sorry about that. So what we know then is that this is going to be 2/3. And sure enough, it's 2/3. Okay? There's also going to be a very fast way, a very quick method of determining what the standard deviation is. So instead of going through this whole process, being that we know that it's a binomial event, how do you determine what the standard deviation is? The standard deviation is very simply going to be calculated by the square root of n, p, and q. Okay? So if we go about doing this here, let's take a look at what those values are again. We said that n, which is the number of times that we're doing when we're doing the experiment, is 2. P, which is the probability of getting a head, which is 1/3, times it by t, which is the probability of getting the tail. Oh, sorry, that's q. So if we do this calculation here, we come up with the square root of 4/9, which of course is going to be 2/3. And notice that you have consistency with the information by solving it using the longer method. So notice that the mean or the expectation of heads calculated in both ways is going to give you the same result. And in the same respect, if we calculate the standard deviation using the longer method or using this method, you're also still going to come out with consistent results. So the key then is to determine and know whether your event is binomial or not. If it is a binomial event, calculating the mean and the standard deviation is very, very simple. Okay, good luck on section 29F.
I'm hoping that you recognize that there was an error in one of my formulas. So anyway, here's the error. So I'm hoping that all of you were able to spot that and notice that the wrong equation is what was in the video and the correct equation is what is listed at the bottom. So please make sure to make that correction in your notes. Thank you.